Hello, today we will continue our conversation about linear lines. This is part 2 of a two-part series. I will link part 1 in the description below. In part 1, we looked at how to identify and solve for the slope of the line and the special properties of slope, including horizontal and vertical slopes. In this video, we will look at how to solve equations utilizing that information, both in point slope form and slope intercept form. When we left off, in part 1, we introduced the point slope form, which we can see here on the screen. We know that to solve for the slope point form, we need to solve for slope, which is the change in y over the change in x. And then what we do is we make y and x of one of the points arbitrary, so we can use any point on the line, and we subtract a point from that. So we do y minus y1 over x minus x1, which is equal to the slope. From there, we move the x values to the right side so that it's on the same side as the slope m. And then that leaves us with the equation that we have highlighted here, which is y minus y1 equals the slope multiplied by x minus x1. And again, I've linked part 1 in the description below if you need a refresher on how to do this. Using a previous example from part 1, we had point that was at 1, 1, and we had a slope that was at 5 over 3. Given this information, let's try to find the equation for this line. All we need to do is fill in the information that we have into this formula. With that, we are given a point at x1 and y1, and we are given slope. So let's add that information into the equation. So we have y minus y1 is 1, and this is equal to our slope, which is 5 over 3, and we have x minus x1, in this case it is 1. Simplifying this problem, we have y minus 1 equals 5 over 3x minus 5 over 3. Moving variables to the left side and moving constants to the right side, we're going to have y minus 5 over 3x. All we did was subtract this 5/3 x from the right side and move it to the left side. And we're going to bring this 1 over to the right side. So this is equal to negative 5 over 3 plus 1. When we simplify, we're left with y minus 5 over 3x equals negative 2 over 3. If you need a refresher on how to add fractions, I will also link a video in the description below. And this is our answer. So from the point slope form, we were able to find a desired form for the equation of a line, which is y minus 5 over 3x equals negative 2 over 3. Let's look at another example. Okay, in this example, we are given 2 points. We have negative 3, 2, and we have the point 5, negative 4. And the question asks us to find an equation for the line. So what do we know? The equation of the line that we know now is the point slope form, which is y minus y1 equals mx minus x1. We already know y1 and we know x1. But what are we missing? We're missing m. So we need to solve for m first. So how do we solve for m? Well, m equals to the change in y over the change in x. That is equal to y2 minus y1, because we're using these 2 points, divided by x2 minus x1. Plugging these numbers in, we're going to choose this point as our y2, x2 value. So we're going to plug in our y value there, and we're going to plug in our x value there, and then minus, we're going to use the y value of our other point, which is a negative 4, so that becomes a plus 4, and we have minus 5. This is equal to 6 over negative 8. And this is equal to negative 3 over 4, which again is equal to m. Now that we know m, we can plug in all the values of this equation. And it doesn't matter for your x1 and y1 value, which one you choose. I'll show you both ways to prove that it doesn't matter. But in this case, we already circled negative 3, 2, so let's just use that. So in our equation, we have y minus, and we have y1, in this case it's 2, and this is equal to m, which we found is negative 3 over 4, and this is equal to x minus, and we're using 3, so plus 3. When we simplify, we get y minus 2 equals negative 3 over 4x minus a 9 over 4. So now bringing the variables to the left and bringing your constants to the right, we have y plus 3 over 4x. Again, we added 3/4 x to both sides, so it cancels it out on the right side, brings it over to the left side, and now we're going to add 2 to the left side, and we have to add 2 to the right side. So 2 minus 9 over 4. To further simplify, we're going to get y plus 3 over 4x equals negative 1 over 4. And this is our equation. Just to prove to you that you're going to get the exact same answer if we use the other point. So instead of using negative 3, 2, we're going to use 5, negative 4 as our point y1 and x1. If we plug this in, we're going to get y minus, we have a negative 4, so plus 4 equals, we have m, which is negative 3/4, multiplied by x minus 5. All right, if we simplify, we get y plus 4 equals negative 3/4 x plus 15 over 4. We're going to bring the variables to the left, and we're going to bring the constants to the right. In this case, we're going to get y plus 3 over 4x, and this is equal to a negative 4 plus 15 over 4. When we simplify, we get y plus 3 over 4x equals negative 1 over 4. And we see that this is the exact same answer. It doesn't matter which point you use, either will work and give you the exact same answer. Now that we understand the point-slope form of the equation of a line, let's look at the most popular equation for the line, which is equal to y equals mx plus b. Also known as the slope-intercept form for the line of any equation. To get to y equals mx plus b, essentially what you're doing is you're further manipulating the point-slope form for the equation of a line by solving for y and then setting negative mx1 plus y1 to b. And so if you have your arbitrary value y minus y1 equals mx minus x1, then what you're doing is you're solving for y, which means you're bringing this value over to the right side. You're left with m multiplied by x minus x1, and now we're adding y to this side. If we simplify, we get y equals mx minus mx1 plus y1. And again, what you're doing is you're just substituting out this portion here to b. And this then is rewritten as y equals mx plus b. Now, this negative mx1 plus y1, or b, is the intercept of the y-axis. You don't really have to understand this proof, but basically what this proof is telling us is if we plug in the point 0b, or 0 negative mx1 plus y1, what that's going to tell us is where this intersects with the y-axis. If we plug in the point 0b, we will see that the line containing the slope m will pass through the point 0b, or the intersection of the y-axis. And so looking on a graph, we see that 0b is somewhere on this y-axis. That could be here, that could be here, that could be here. It just says that at this point, we are crossing the y-axis. In this equation, y and x are your points along the line, m maintained as your slope, and b is your y-intercept, or where it crosses the y-axis. This form of the equation becomes a lot more beneficial to use because you can see more details about the line in a shorter amount of time. Again, you can use point-slope form, but if you manipulate point-slope form, then you can get the y-intercept form, and this form is the most convenient form for the equation of a line. Again, depending on your teacher or class, they may ask for the other form of the equation. They are similar to one another, but typically you'll see y equals mx plus b as the equation for a line. Let's look at a few examples using the y-intercept form. Say you're given a point -6, 8, and 1, 2, and you're asked to find the equation of the line. Using the equation that gives us the most bang for our buck, let's use the intercept form, y equals mx plus b. And all we need to do now is solve for our variables. We need to solve for m, and we need to solve for b. Well, we know m is equal to the change in y over the change in x. If we use this as our y2 and x2 values, then this is equal to y2 minus y1 over x2 minus x1. Then this is equal to y2 is 8, and we have our x2, which is -6, and we're going to minus 2, and we're going to minus 1. This is equal to 6 over -7, and this is equal to m. Now what we need to do is solve for b. Well, we have y, and we have x, and we can use any point in here similar to what we did in our last example. So using the point 1, 2, because it's a smaller number, let's plug that number in. 2 equals m is our slope, is 6, -7, x is 1, and we get plus b. Now we're solving for b. At b, we're getting 2 equals 6, -6/7 plus b. If we move -6/7 to the right side, we are left with 2 plus 6/7 equals b. From there, we simplify, and we see that b is equal to 20/7, which is equal to 2 6/7. Now that we have m and we have b, we can plug this into the equation, and our final answer would be y equals -6/7x plus 2 6/7. And this is the equation of our line. With this equation, we know that the rise is down 6 and then over 7 for the run, for our slope. And we know that it crosses the y-intercept at 2 6/7. If we wanted to look at this on a graph, and this may not be drawn to scale, we would go over -6. So 2, 4, 6. And we're going to go up 8, 2, 4, 6, 8. And -6. And this is our first point. And then we're going to go over 1 and up 2, so right here. And then we would draw this line. And we're saying that this is approximately 2 6/7, and that is exactly where this says this crosses the y-intercept, right there. So that's why this equation is so important and so convenient, because we get a lot of information about this line without even having to graph it. Let's look at another example. So say you have the point -2, 3 and 4, 3. Well, we can see here that both the y-axis values are the same, which tells us that this is a horizontal line, because if we go over -2 and up 3, we have it here, and if we go over 4 and up 3, then we're here, and we're on this horizontal line. And we learn that a horizontal line has a slope that is equal to 0. If you don't remember that, you can always calculate it by doing the change in y over the change in x. In this case, it's going to be 3 -2 minus 3 minus 4. And we're going to get 0 over -6, which is equal to 0. So that's how we know that this is a horizontal line. And if we wanted to find the equation of the line, we would do y equals mx plus b. We can see that because we've graphed it, we can see that it's going to cross at 0, 3. But if we wanted to check that, then all we would need to do is plug in our points. So we get y, let's choose the point 4, 3. So we get 3 equals 0 times 4 plus b. In this case, 3 equals b. And that is exactly what we get here. And the equation, if we write it, is plugging in the values. Y equals m is 0, so we don't need to do anything with this point because 0 times x is 0, plus 3. And this is simplified to y equals 3. And this is the equation of the horizontal line that goes through the points -2, 3, 4, and 3. Let's look at one last example. Looking at our last example, we have the point 4, 4 and the point 4, -1. Well, this is very similar to the last example in that we see that the x values instead of the y values are the same. So if we wanted to, we could graph it just so we can see what we're talking about. And we get a value of 4, and we get 4, 4, which is here. And then our other point is 4, -1, which is here. So that shows between those 2 points that the line is going this way. We learned from part 1 that a vertical line has a slope that is undefined. Right? But if you don't remember that, we're able to solve for that. If we wanted to write an equation for this line, we would use y equals mx plus b. In this case, this is our slope-intercept form. And we can already tell right now that there is no intersection between the y-axis. So we know that b does not exist, or b is 0. There's no value that it's going to cross the line. But again, we can solve for this. If we want to solve for this, then we can find slope, but we know that slope's going to be undefined. But just in case you don't remember, we can use the point 4, -1 as our x2, y2 value. So we do -1 minus 4 divided by 4 minus 4. In this case, we're going to get -3 over 0, and this is undefined. Okay, because m is undefined, and because b does not have a real answer, the equation of this line becomes x equals 4. And this states that x is equal to 4 on all points of y. If we want to look at this first point, we have x is 4, and then we also have a value of y at 4. That satisfies this equation. If we go x to 4, and then we go to the point -1, that also satisfies this point, which means it satisfies this equation. All vertical lines has an equation that is equal to where it crosses at the x-axis, not the y-axis. So that's just something to keep in mind when looking at vertical lines versus horizontal lines versus diagonal lines. And there you go. Now you understand, looking at part 1 and part 2, how to identify and solve for the slope of a line. We also looked at special properties, including horizontal and vertical lines, and we looked at how to solve equations using the point-slope form and the y-intercept form. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe to this channel, and we'll see you next time.